Hello, Mrs. Pretty. This is my vectors video assignment. Okay, let's start with the first question. Our first question asks us for an airplane heads due to north with a velocity of 400 kilometers per hour. What this is asking for us is the resultant velocity of the airplane. So first we have to find the magnitude with plane's velocity and wind's velocity are written down the values, and since the wind is coming from northeast, it goes towards south west. Therefore it has an angle of 225 degrees. This is how we find the components of the wind's velocity. Then to find the magnitude of both of these velocities, we add them up, and this is the result we get. And to find the okay, sorry. To find whether it does lie or it doesn't on this plane, we have to plug in our new vectors equation into the points given here. So for x, we use a's point as a starting point. Therefore, 2 plus s4. We do this for all the parts, and we get something like this. And it equals to 0. Then we can say that therefore it does lie on the plane, because we can get the values we want. Okay, now let's move on to the fifth part. It has for intersection of planes, and want us to find the formulas for that. First, we have to look if they are parallel or not. If they are parallel, for them to intersect, they have to be coincident. But if they are not, they should intersect at some point if they are not parallel, and they are not skewed. Okay. For the first one, we had something like this, two equations of the planes, and when we check for their if they are parallel or not, we can see that they are not parallel since their normal vectors are different vectors. Then we use cross product to find the direction. After that, we can move on. Okay, now we have to look what the equations will give us when we set z value for 0 to find the line that passes through them, intersects with them. When we first put the z value for the first equation, we get something like this, and it tells us that x equals to y plus 1. Then we plug in the new x value we got to the second equation, and it gives us this 3y equals to minus 3, therefore y equals to minus 1. And now we see that our starting point is this, since our x value is 0 and z value is 0. Then we add it up with our direction vector, which we found by cross product of two normal vectors, and this is the point of intersection. Now let's take a look at the second part, B part, and we can directly see that 2 points are parallels since they are multiples of each other. X, 2x, minus 4y, minus 6y, 8y, plus 7z, plus 14z. They all match. Now we have to ask if they are coincident or not. If they are not coincident, there won't be any points of intersections. But if they are, then all of the points are some points of intersections. And we can see that they are not by multiplying the first equation of part B by 2, we get 56, but 56 doesn't equal to 60, therefore